Differentiation is used widely in solving problems, especially in engineering, medical, commerce, agriculture, and many other fields. Another name for differentiation is the derivative of the function.
This song is great, bro. You have to hear this song, Boogie Man. Yeah. Boogie, Boogie Man, Boogie, Boogie. Here we come, bro. Oi! Boogie, Boogie Man. Hey guys, what's going on? Flat, going flat.
Did you guys know that you can use differentiation to make your punches stronger?
You think your punch is stronger enough?
No, I'm not strong, but watch this.
We're going to use differentiation to find your acceleration. I know your mass is 55 kg and I know your speed of your punch is 12 seconds square plus 3. And we use this technique to find the first order of differentiation. And time taken for you to punch, I know it's 3 seconds. And we can apply the same technique to find the acceleration, which we substitute the second with 3, and we can find the force of your punching. That's what I said, your punch is not strong enough. And for you, we apply the same technique, use differentiation to find the acceleration. And then we can go through and know how much strength you got. And from here, I can tell that your punch is stronger, but you're late for a second. You need to be faster.
Okay, now we are moving to the question. First is question A. The question is y equal to x power of 3 minus 3x power of 2. First, we must differentiate to find expression for dy over dx. So after we differentiate, we get 6x power of 2 minus 6x. Second, we have to find the coordinates of any stationary point on the curve at stationary point. Let's dy over dx equals 0. So cs power of 2 minus 6s equals 0. After we factorize 6s column s minus 1 column equals 0. We get s equals 0 and s equals 1. When s equals 0, y equal to column 0 power of 3 minus 3 column 0 power of 2. Then we get y equals 0. When s equal 1, y equal to column 1 power of 3 minus 3 column 1 power of 2. Then we get y equal negative 1. The stationary point are 0, 0 and 1, negative 1. Third, the answer for how many stationary points does the graph have is 2.
0. So when y equals to 0, firstly we have to factorize it first, like this. 2x minus 3 equals to 0. So the first x will be x power of 2 equals 0. X will be 0. The second x is 2x minus 3 equals 0. So 2x equals to 3. So x will be 3 over 2 or 1.5. The y-intercept points are 0, 0 and 1.50. So when x equals to 0, we have to replace x with a value that we get, like this. Y equals 2 column 0 power of 3 minus 3 column 0 power of 2. So y will be 0. So the x-intercept point is 0, 0. So the nature of any stationary points that I get is 12x minus 6. So when x equals to 0, d power of 2y over dx power of 2 equals 12 column 0 minus 6. So the answer will be negative 6 less than 0. So for the final step, we have to plot the graph. That will be our final answer.
Okay, next for question H, which is y equals to x cubed plus 6x squared minus 5. First, we have to differentiate this expression and we will get dy over dx equals to 3x to the power of 3 minus 1 plus 2 times 6 x to the power of 2 minus 1, and if we differentiate negative 5 we will get 0. So next we will solve it and we will get 3x squared plus 12x. So for part 2 we will find the coordinates for any stationary points on the curve. So first we will let dy over dx equals to 0, and then we will rewrite the equation that we got earlier, which is 3x squared plus 12x equals to 0. Then we can see that there's a common factor, so we can write it. We'll get 3x plus 4 equals to 0. Then from this we will be able to find the values of x. The first value of x is equals to 0. The second value is x plus 4 equals to 0. X equals to negative 4. Then after that, we will use these values of x to find the values of y. When x equals to 0, we will replace the values of x into the equation and we will get the value of y. So y equals to 6x squared minus 5, and after we insert the values, y is equals to negative 5. When x is equals to negative 4, we will replace the values of x and we will get negative 4 to the power of 3 plus 6 times negative 4 to the power of 2 minus 5, and we will get that the value of y is 27. So now that we have all the values, we can create the coordinates. The stationary points are 0, negative 5, and negative 4, 27. So for part 3, based on part 2, we will be able to say that there are two stationary points, which is 0, negative 5, and negative 4, 27. Okay, now we are going to determine x-intercept and y-intercept point. First, take the coordinate 0, negative 5. subs x equals to 0 into y. Your final answer will be -5. So that means the intercept point is 0, -5. Now moving on to y, -5. Do the same thing as the previous one, and your final will be x cubed plus 6 squared. If this happens, you have to take out the common factor. Now solve the x. Okay, now that means the x-intercept point are 0, -5, and -6, -5. To determine the nature point of any stationary point, you have to use the method second degree. Now the first degree, now we are going to do the second degree. 6x plus 12, that's it. Now this I take from part 2, coordinate part 2. So when x equals to 0, d2y per dx equals 6 times 0 plus 12. So the answer will be 12 is more than 0. That means the point 0, -5 is minimum point. So when x equals to -4, d square y per over dx square is 6 -4 plus 12. So the answer will be 12 less than 0. That means the point coordinates -4, 27 is maximum point. Now we have all the coordinates. -6, -5, 0, -5. Okay, now we have to plot only. -4, 27. Here. -6, -5. 0, -5. This is the final answer for part 6. To summarize, differentiation is a method of finding the derivative of a function. It is also an important tool in calculus that allows us to determine the rate at which a function changes.